Hi, in this lecture we will see a few practice questions on vector algebra. Cool, let's start. So this is the first question. It is a multiple select question. Let a vector be 2 comma minus 1 comma 3, so it is in 3-dimensional space, and b vector is 1 comma 2 comma minus 2. Which of the following is or are correct? First is their dot product is 0. So what is the dot product of vector a and vector b here? Vector a dot vector b will be 2 into 1 minus 1 into 2, so plus minus 1 into 2 and 3 into minus 2. So this will be the dot product. It will be 2 minus 2 minus 6, which is minus 6. So the dot product of vector a and vector b is minus 6. It is not equal to 0, it is minus 6. So option A is incorrect. Second is magnitude of vector a is square root of 14. So the magnitude of vector a will be square root of 2 square plus minus 1 square plus 3 square. So it will be 9 plus 4, 13 and 1, 14. So it will be square root of 14. So magnitude of vector a is square root of 14. So this option is correct. Next is angle between a and b is 90 degrees. So we know that two vectors are orthogonal or their angle is 90 degree if and only if their dot product is 0. Here their dot product is not 0. So the angle will never be 90 degrees. But if you want, we can find the angle. So cos theta will be a vector dot b vector upon magnitude of a vector times magnitude of b vector. So it will be minus 6 upon square root of 14 times the magnitude of vector b. Magnitude of vector b will be 4 plus 4 plus 1, which is square root of 9. Okay, so this will be the value of cos theta. So cos theta is negative here and hence the angle will be between 90 and 180 degree. Okay, so here the angle between vector a and vector b will be an obtuse angle. Okay, it is definitely not 90 degree. Okay, it will be between 90 degree and 180 degree. So option C is incorrect and the magnitude of vector b is square root of 9. We just calculated it, so it is correct. Magnitude of vector b will be square root of 1 plus 4 plus 4, which is square root of 9. Option D is correct. Okay, option C would have been correct if the dot product would have been 0, but the dot product is not 0, so option A and C are incorrect. Option B and D are correct here. Okay. Cool. Moving on to the next question. Find the sum of L1, L2 and L infinity norms of vector x, where vector x has 3 components, 3, 4 and minus 5. Okay. So what will be the L1 norm of this vector? L1 norm will be just the absolute values sum. So it will be absolute value of 3 plus absolute value of 4 plus absolute value of minus 5. So it will be 5 plus 4, 9 and then 3. 5 and 4, 9 and 3, 12. Okay, so it will be 12. What will be the L2 norm? L2 norm will be the square root of 3 square plus minus 4, plus 3 square plus 4 square plus minus 5 square, which will be square root of 25 plus 16 plus 9. 9 plus 16 plus 25. So it will be 25 and 25, 50, which is 5 root 2. 5 root 2. Okay. And what is the max norm? The max norm will be just the maximum value of the absolute values here. So absolute value of 3 and absolute value of 4 and absolute value of minus 5. So the absolute value, maximum absolute value is 5 here. So it will be 5. Okay. And in general, always use the formula. So the pth norm is the like a1 to the power p plus a2 to the power p and so on, an to the power p whole to the power 1 by p. We can use this. Okay, so this is the max norm, and if you have to find the sum of all these, L1 plus L2 plus L infinity will be in this case 12 plus 5 root 2 plus 5. So it will be 17 plus 5 root 2. 17 plus 5 root 2. So you can, like, this is a numerical answer type question, you can calculate this value and whatever the value is, that will be the answer. Okay, 17 plus 5 root 2. Okay, so the value will be 24.07. Cool. Moving on to the next question. If u and v are orthogonal non-zero vectors in n-dimensional space, which of the following statements is or are true? Again, a multiple select type question we have. So u and v are two orthogonal vectors, orthogonal and non-zero vectors, which means if they are orthogonal, their dot product is 0. We know that. And the angle between them is 90 degrees. cos theta will be 0 and the angle between them is 90 degrees. This is all the information that we know. Okay, so based on this, option B is definitely correct because the dot product of vector u and vector v is 0. And the first option is u plus v, the magnitude of u plus v square. So what will be this? So we have to calculate the magnitude of u plus v square. U plus v is a vector, right? So if let's say u has a components, if u has the components u1, u2 and so on un, and the vector v has components v1, v2 and so on vn, they are both in n-dimensional space, it is given, right? So this is also in n-dimensional space and this is also in n-dimensional space, which means they both have n components each. Then u plus v will also be a vector in n-dimensional space. Its components will be u1 plus v1, u2 plus v2 and so on, un plus vn. Okay, this will be the vector u plus v, and we have to calculate its magnitude square. So the magnitude of u plus v will be square root of u1 plus v1 square plus u2 plus v2 square and so on, un plus vn square. This will be the magnitude of the vector u plus v, right? And we have to take the square of that, which means the magnitude of u plus v whole square will be, the square root will go away, right? Because we are taking the square. So it will become u1 square plus, I will just take u1 square, u2 square, un square together, u1 square plus u2 square plus un square. And if I take all the v1 squares terms together, I'll get v1 square plus v2 square plus vn square. Then we will get 2 u1 v1, 2 u2 v2, 2 un vn. So I can write it like 2 times u1 v1 plus u2 v2 and so on un vn. So I just expanded the square, like square of u plus v. So the magnitude of u plus v whole square, and it just came out to be this entire term is nothing but magnitude of u1 whole square. Magnitude of u1 whole square, and this entire term is nothing but magnitude of v1 whole square. Magnitude of not u1, it's magnitude of vector u. So it will be the magnitude of vector u whole square plus magnitude of, this is the magnitude of vector v whole square plus 2 times this entire term is nothing but the dot product of u and v, right? This is the dot product of vector u and vector v. So it will be 2 times vector u v u dot vector v, the dot product of u and v. So this is what u plus v magnitude whole square is. It is u square, the magnitude of u square plus magnitude of v square plus 2 times the dot product of u and v. And since u and v are orthogonal, in this case, since u and v are orthogonal, their dot product is 0, which means this term is 0. And hence the magnitude of u plus v whole square actually is equal to magnitude of u square plus magnitude of v square, which is option A. Option A becomes correct. Now third option is the u vector will be k times v vector. So which means they are both pointing in the same direction, right? If u vector is k times v vector, it means that if this is my vector v, and then k times vector v will also be in the same direction, and hence the angle between these two will be 0 degrees, right? If option C is correct, then the angle between these two is 0 degrees. But here they are saying they are orthogonal, which means their angle between them is 90 degrees. And hence option C is incorrect. Because in option C, the angle will be 0 degrees, not 90 degrees. But the angle between them is 90 degrees. Option D is angle between them is 90 degrees, which is correct. The angle between vector u and vector v is 90 degrees if they are orthogonal to each other. Orthogonal is also another term for perpendicular. So they are perpendicular to each other, and options A, B and D are correct. Okay, let's look at the next question. This is a numerical answer type question. Find the cosine of the angle between this vector and this vector. So both the vectors have 3 components each. So let's say this is the vector u and this is the vector v. Then I have to find the cos theta, which means the cos of angles between the vector u and vector v. So we know that cos theta is nothing but u vector dot v vector upon magnitude of u vector times the magnitude of v vector, right? So the dot product of these two will be 1 into 1 plus 1 into 0 plus 0 into 1 upon the magnitude of u vector is what? It is the square root of 1 square plus 1 square plus 0 square, and the magnitude of vector v is 1 square plus 0 square plus 1 square. So it will be 1 plus 0 plus 0, which is 1, upon square root of 2 into square root of 2, which is square root of 2 into square root of 2 is 2. So it is 1 by 2. And hence the cos theta, the cos of the angle between these two vectors is half. This is what they want. They want to find the cosine of the angle. Read the question carefully. They are not asking the angle. They are asking cosine of the angle. So cosine of the angle is 0.5. This is the answer. But if they ask the angle as well, cos theta is 0.5 means theta is 60 degrees. Okay. If they wanted to ask like the angle, you can say that the angle is 60 degrees because cos 60 degrees is 1 by 2. Okay, so the cos theta here is 0.5, the answer will be 0.5. Cool. Moving on to the next question, we have a vector A 1, 2, 3 and vector B 4, 1, 2. Then which of the following statements is or are true? Multiple select type question again. So first is their dot product is 8. So the dot product of vector A and vector B will be what? It will be 1 into 4 plus 2 into minus 1 plus 3 into 2. Okay, so it will be 4 minus 2 plus 6. 4 minus 2 plus 6, which is 2 plus 6, which is 8. And hence the dot product of vector A and vector B will be 8. So option A is correct. Now option B is the magnitude of vector A is square root of 14. So the magnitude of vector A will be square root of 1 square plus 2 square plus 3 square. So it is 9 plus 4 plus 1, which is 9 plus 5, which is 14. So it is square root of 14, and hence the magnitude of vector A is square root of 14, which is option B. So option B is correct. Then the projection of vector A and vector B has a length of this much. Okay, so what is the length of the projection? We know this. Length of the projection of vector A on vector B is nothing but vector A times cos of angle between these two, right? Vector A times the absolute the magnitude of vector A times the cos of angle between these two. So it will be magnitude of vector A times cos of angle, because that is the component, that is the length. So magnitude of vector A is square root of 14 and cos theta is vector A dot vector B upon magnitude of vector A times magnitude of vector B. So it will be root 14 into 8, the dot product is 8, upon magnitude of vector A is square root of 14 and magnitude of vector B will be what? Magnitude of vector B will be square root of 16 plus 1 plus 4. So it will be square root of 21. It is square root of 21. So if I plug the value here, we'll get this, and hence these two will cancel and we'll get 8 upon square root of 21. This is the length of the projection. This is the length of the projection of vector A on vector B, which is 8 upon square root of 1, and hence it is correct. Now the angle between them is acute. So how do we solve these type of questions? For any two vectors, the angle between them is acute. Acute means between 0 and 90 degrees. So we can write this thing as like theta will be 0 degree. Like if theta will be 0 degree if, so let us try to write all the rules for acute angle and obtuse angle and all. Okay. So we know that cos theta is what? We know that cos theta is A vector dot B vector upon magnitude of A vector times magnitude of B vector, and hence theta is cos inverse of this. This is what cos theta is. Now the denominator is magnitude into magnitude. Magnitude of any vector is always positive, right? The magnitude or the size of the vector length is always positive, and hence both of these are always positive. So the denominator will always be positive. Now it all depends on the numerator. Okay. So firstly, when will theta be 0 degrees? Theta will be 0 degrees, which means both the vectors are parallel to each other. They both have the same direction, right? Then the angle between them is 0, right? Which means cos theta will be 1. It means that their dot product is essentially equal to the product of their magnitudes. In that case only, the angle will be 0. And we can also say that vector A is actually parallel to vector B. They both have the same direction. Okay, or we can say that vector A is some scalar times vector B. Okay, cool. And theta will be 90 degrees if cos theta is 0, which means the dot product of these two vectors must be 0. If the dot product is 0, then the angle is 90 degrees. Now, if cos theta is positive, then it means that theta will be somewhere between 0 degrees and 90 degrees. Right? Then only, because if cos theta is positive, you can check the graph of cos, right? How does cos theta look like? Cos theta looks like this: 0, then 90 degrees, then 180 degrees. Cos 90 is 0 and cos 0 is 1 and cos 180 is minus 1. So it looks like this, right? So if the angle between, if cos theta is positive, it means that the angle between these two vectors is between 0 and 90 degrees. And if cos theta is negative, then it means that the angle between these two is between 90 and 180 degree, which means here the angle is acute, and if cos theta is negative, it means that the angle will be between 90 degrees and 180 degrees. It means that the angle is obtuse. Okay, it is an obtuse angle. So the vectors will look here like something like this, and here the vectors will look something like this. Okay, so the angle will be obtuse, here the angle will be acute. Okay, so these are the rules which you can see here from the formula. And here the dot product was positive. Here the dot product was positive 8. Since the dot product was positive, we can say that the angle between them will be acute. It will be an acute angle. Okay, so option D is also correct. So all the options A, B, C, D in this question are correct. Okay, cool. A, B, C, D all are correct. Okay, let's look at the next question. Find the Euclidean distance between vector 1, 2, 3 and vector 4, 6, 9. So what is the Euclidean distance? It is the L2 distance, or the Euclidean distance between vectors, which is just the square root of 1 minus 4 whole square plus, like you just have to take component difference and take the square of that, plus 2 minus 6 whole square plus 3 minus 9 whole square. So it will be square root of 3 square plus 4 square plus 6 square. So it will be square root of 9 plus 16 plus 36. Okay, so 9 and 6 is 15, 15 and 6 is 21. So 5, 6, square root of 61. So this is our answer. This is the Euclidean distance between these two vectors, square root of 61. Okay, whatever this value is, it will be around 7.8 something. Okay, square root of 61, 7.81. Okay. Moving on to the next question. Which of the following is or are true for any vectors A and B? Okay, for any two vectors A and B, which of the following statements are true? So option A we have already seen, right? We have already proved it here in the previous question, in question number, okay, let's try to see here. In question number 3 we have proved it. For any two vectors, the magnitude of u plus v square will be magnitude of u square plus magnitude of v square plus 2 times u vector dot v vector. We have already proved it. Okay, and hence here also the same question has been asked. Magnitude of a vector plus b vector whole square will be magnitude of a square plus magnitude of b square plus 2 times a vector dot b vector. We have already proved it. Option A is correct. And if they are orthogonal to each other, a dot b will become 0. Now following the same proof, we can prove option B as well. It's very simple. A vector minus b vector whole square will again be, so vector A minus vector B will have components what? A1 minus B1, A2 minus B2, and so on, An minus Bn. And hence the magnitude of A vector minus B vector whole square will be what? It will be A1 minus B1 whole square plus A2 minus B2 whole square, A2 minus B2 whole square, and so on, An minus Bn whole square, right? And there will be a square root which will cancel with the whole square. Cool. So you can take all the a1, a2, an terms together and you can write it as magnitude of a vector whole square, and you can take all the b terms together and you can call it magnitude of b vector whole square, and minus 2 times you will have a1, b1, a2, b2 and so on. So you can write it a vector dot b vector, and hence yes, magnitude of a vector minus b vector whole square will be a square, magnitude of a square plus magnitude of b square minus 2 times the dot product of these two vectors. Option B is also correct. Now option C is the magnitude of the dot product of any two vectors will always be less than or equal to the magnitude of a vector times the magnitude of b vector. So there is a very simple proof of this. This particular inequality is called Cauchy-Schwarz inequality. It's a very famous inequality in vectors, and we can prove it very easily. We know that the dot product of any two vectors is what? The dot product of any two vectors is the magnitude of a vector times the magnitude of b vector times cos theta, where theta is the angle between them. Now these two values are anyways always positive. These two values are anyways always positive, and hence the absolute value of a vector dot b vector will be the magnitude of a vector times the magnitude of b vector times the absolute value of cos theta times the absolute value of cos theta. Now cos theta always lies between minus 1 and plus 1, and hence the absolute value of cos theta will always lie between 0 and 1. So this particular value will always lie between 0 and 1, and hence this entire value will always be less than or equal to magnitude of a vector times magnitude of b vector. Very easy proof, right? And hence the dot product's absolute value will always be less than or equal to the magnitude of vector a times the magnitude of vector b, because cos theta magnitude always lies between 0 and 1, and hence option C is also correct. Okay. In option D they are saying magnitude of vector a plus vector b, vector a plus vector b magnitude will always be less than or equal to magnitude of vector a plus magnitude of vector b. Again, this is called the triangle inequality, and this also holds. Why? So what is the magnitude? It is the distance from the origin, right? Magnitude of any vector is what? It is the distance of the point from the origin. So if this is vector a, then the magnitude is this length, right? And let's say this is vector b, then this length is the magnitude of vector b, and a plus b will what? A plus b will be what? From a b you start writing a, right? We have already seen the geometric interpretation, so let me draw it in the next page. So what I'm trying to say is, this is, let's say I'm drawing in a 2D, okay? So let's say this is vector a, okay, and this is vector b. Then a plus b vector will be what? Like you can just draw a parallel line from vector a, and this will be vector a plus b. This will be vector a plus b, right? And hence the length of this vector, and hence the length of vector a plus b, the length of vector a plus b will always be less than or equal to the length of vector a plus the length of vector b from triangle inequality. For in any triangle actually this thing holds, right? In any triangle, if it has sides a, b and c, then any side will always be less than or equal to the sum of the other two sides. And based on the triangle's inequality, I can say that the length of vector a plus b will always be less than or equal to the length of vector a plus the length of vector b. Okay, so yes, this thing will always hold true because of the triangle inequality. Okay, and hence option D is also correct. Okay, options A, B, C, D all are correct here. Cool, all are correct. Okay, let's look at the next question. Find the length of the projection of vector A, which is 1, 2, 2 on vector B, which is 2, 1, minus 1. So we know that the length of the projection of vector A on vector B is what? It is the magnitude of vector A times cos theta, where theta is the angle between these two. So it is the length of the vector A times A vector dot B vector upon magnitude of vector A times magnitude of vector B. Now these two cancel and we just get the length of the projection as this much. This will be the length of the projection, right? So here the dot product will be, the dot product of vector A and vector B will be 1 into 2 plus 2 into 1 plus 2 into minus 1. So it will be 2 plus 2 plus 2 plus 2 minus 2, which is 2. And the magnitude of vector B will be what? It will be square root of 2 square plus 1 square plus minus 1 square, and hence it will be square root of 4 plus 1 plus 1, which is square root of 6. Okay, and hence the length of the projection will be equal to the dot product, which is 2 upon the length of the B vector, which is square root of 6. So this will be the length of the projection, 2 upon square root of 6. Okay, you can calculate the exact answer. 2 upon square root of 6 will be the length of the projection of vector A on vector B. Cool. So it will be 0.816. Moving on to the next question. Projection matrix onto the vector B is. So you are given a vector B as a column vector, and we want to find the projection matrix on this vector. Okay. So we know that the projection matrix on any vector B is nothing but BB transpose upon B transpose B, right? We have already seen this. So firstly, let's try to calculate B transpose B. B transpose B will be a scalar. It is just the magnitude of B vector square. Okay, so we can write it like this. It will be 1, 2 times 1, 2. So it will be just a 1 cross 1 matrix having the value 1 plus 4, which is 5. Okay, it will be 5. Now BB transpose will be 1, 2 times 1, 2. So it will be a 2 cross 1 vector matrix multiplied by 1 cross 2 matrix. It will be 2 cross 2 matrix. And the values will be 1, 2 and then 2, 4. And therefore the projection matrix on vector B will be 1 by B transpose B, which is 5, 1 by 5 times 1, 2, 2, 4. Okay, so this is the projection matrix. Cool. And which matches with option A. Option A is 1 by 5 times 1, 2, 2, 4. And hence this is the projection matrix, correct projection matrix. Okay. And you can multiply this matrix with any vector to get the projection of that particular vector on vector B. Okay. Cool. So option A is correct. Moving on, compute the Manhattan distance between point 0, 0, 0, 0 and 1, 1, 1, 1, 1 in R10. Okay. So we have to find in R10, which means both these vectors are having are in 10 dimensional space. So they have 10 components each. They both have 10 components each. And the Manhattan distance is very simple. The Manhattan distance is what? It is the L1 distance. Okay, will be 0 minus 1 absolute value plus 0 minus 1 absolute value and so on. 0 minus 1 absolute value 10 times. This will be occurring 10 times. Okay, so it will be 1 plus 1 plus 1 10 times. So it's a very simple question, and hence the Manhattan distance will be equal to 10. Okay, so the Manhattan distance between these two vectors is 10 units. Cool. So the answer will be 10. Okay. Cool. So these are all the questions on vector algebra. And yeah, in the next module we'll start some other interesting concepts, which is vector spaces and subspaces. It is one of the most important concepts related to the exam. So yeah, thanks for watching the lecture. Let's meet in the next lecture. Bye bye.